Good day, students. Welcome to our lesson this week. Today we're going to talk about the parabola. So what is a parabola? It is one of the conic sections. It is a set of all points in a plane equidistant from a fixed point and the fixed line in the plane. The fixed point is called the focus of the parabola and the fixed line is called the directrix. The line through the focus and the perpendicular to the directrix is called the axis of the parabola, and the point where the parabola crosses its axis is called its vertex. The chord drawn through the focus and perpendicular to the axis of symmetry of the parabola is called the latus rectum or the focal diameter. If we know the equation of the directrix of a parabola and the coordinate of its focus, the equation and the graph of the parabola can easily be determined. So we have different cases of the parabola. Here we have 8. The first one is the parabola opening to the right. When a parabola opens to the right and the vertex is at the origin or 0, 0, the equation is y squared equals 4px. The focus or the coordinates of the focus is 4, 0. Directrix is x equals negative p. Ends of latus rectum, the coordinates are p plus 2p and p minus 2p. So it is just represented as p plus or minus 2p. And the axis of symmetry is y equals 0. When a parabola that opens to the right has a vertex of hk, not the origin, so the equation is y minus k squared equals 4p times x minus h. The coordinates of the focus is h plus p, k. The equation of the directrix is x equals h minus p. The ends of the latus rectum is h plus p, k plus or minus 2p. And the equation of the axis of symmetry is y equals k. When a parabola opens to the left and the vertex is at the origin or 0, 0, the equation is y squared equals negative 4px. The focus is 4, 0. The directrix equation is x equals negative p. The ends of the latus rectum is p positive or negative 2p, and the equation of the axis of symmetry is y equals 0. When the parabola opens to the left and the vertex is at hk, the equation is y minus k squared equals negative 4p times x minus h. The focus is h plus p, k. The equation of the directrix is h minus p. The ends of the latus rectum is h plus p, k plus or minus 2p, and the equation of the axis of symmetry is y equals k. When a parabola opens upward with the vertex at the origin or 0, 0, the equation is simply x squared equals 4py. The focus is 0p. The equation of the directrix is y equals negative p. The ends of the latus rectum is positive or negative 2p, p, and the axis of symmetry is x equals 0. When a parabola that opens upward has vertex hk, the equation is in standard form is x minus h squared equals 4p times y minus k. The focus is h, k plus p. The equation of the directrix is y equals k minus p, and the ends of latus rectum is h plus or minus 2p, k plus p, and the equation of the axis of symmetry is x equals h. When a parabola opens downward with vertex at the origin or 0, 0, the standard form of the equation is simply x squared equals negative 4py. The focus is 0p. The equation of the directrix is y equals negative p. The ends of the latus rectum is positive negative p P, and the equation of the axis of the symmetry is x equals 0. Lastly, when the parabola opens downward, has vertex hk, standard form of the equation is x minus h squared equals negative 4p times y minus k. The focus is h, k plus p. The equation of the directrix is y equals k minus p. The ends of the latus rectum is h plus or minus 2p, k plus p. And the equation of the axis of symmetry is x equals h. Example. Find the equation of the parabola with vertex at 1, negative 2, axis of symmetry parallel to the y-axis, and passing through negative 1, 2. Graph the parabola. So step 1, plot the vertex and the point. You may use GeoGebra graphing calculator to plot the points. You may also use Mathway, Symbolab, and any other mathematics software. You can also download graphing calculators in your mobile phones. Next is, since the axis of symmetry is parallel to the y-axis, therefore the parabola opens either upward or downward. Based on the position of the vertex and the point, the parabola opens upward. Step 2. Use the equation of the parabola x minus h squared equals 4p times y minus k. We use this formula because the parabola opens upward. We select this equation from the 8 cases that have presented before. Then substitute the values of the given vertex or hk and the point xy to get p. So negative 1 minus 1 squared equals 4p times 2 plus 2. So as you can see, our x is negative 1, so negative 1 here. Our h is 1, so minus 1 square equals 4p times our y is 2. And our h is negative, our k rather is negative 2. So since it is negative 2 minus negative 2, that's why it became plus 2. Then our solution will become negative 2 squared equals 4p times 4. 4 equals 16p. Divide both sides by 16, so we are going to get p equals 1/4. Step 3. Use the equation of the parabola. Then substitute the value of the vertex or hk and the obtained value of p. So x minus 1 squared equals 4 times 1/4 times y plus 2. So as you can see, p was changed to 1/4. Then just continue your solution. X minus 1 squared equals y plus 2, because 4 times 1/4 is 1 times y plus 2, it's y plus 2. Then use squaring of binomial in x minus 1 squared so that it will become x squared minus 2x plus 1 equals y plus 2. Then write x squared and the term with x beside it with each other. So this will become x squared minus 2x minus y plus 1 minus 2 equals 0. Then just simplify, it will become x squared minus 2x minus y minus 1 equals 0. So this equation is in general form. Step 4. Graph the parabola. Here, we use again GeoGebra graphing calculator. So as you can see, that's the vertex and that's the given point. It passes through the parabola. So our answer is correct. Example 2. Find the equation of the parabola with directrix x plus 1 equals 0, axis of symmetry is y equals 1, and the length of the latus rectum is 4. Then graph the parabola. So we need to follow steps again. So we may have different steps in different cases, okay? In problem solving, the important thing is that you are following steps so that you are doing your solution systematically. So here is step 1. Axis of symmetry is y equals 1, so k equals 1 because y equals k. The length of the latus rectum is 4. So remember that the length of latus rectum is equal to 4p. So we can use this LR equals 4p. So 4p equals 4. Divide both sides by 4. We're going to get p equals 1. And directrix is x equals negative 1. So it was obtained from x plus 1 equals 0. 1 was just transposed. Since x equals h minus p, since we have values here of x and p, we can solve for the value of h. So substitute negative 1 to x and substitute 1 to p. So our h is equal to negative 2. So since we have the values of h and k here, we can say that the vertex is negative 2, 1. Step 2, find the following. Axis of symmetry is y equals 1. So the opening is either left or right. Then directrix is x equals negative 1. The vertex was obtained earlier. It's negative 2, 1. Then focus, if you use the value of h, p, and k, you're going to get this negative 1, 1. So focus is h plus p. H is negative 2, p is 1, negative 2 plus 1 is equal to negative 1. And then k is 1. And then ends of latus rectum. So since ends, it means that you're going to get 2 points. And they have the same x coordinate, which is h plus p. So h is negative 2, p is 1, h plus p is negative 1. Because negative 2 plus 1 is negative 1. So as you can see, the x coordinate here are both negative 1. And then k plus 2p and k minus 2p. So k is 1. So 2p is 2. 1 plus 2 is 3. And then k, 1, 2p is again 2. So 1 minus 2 is negative 1. That's why we got negative 1, 3 and negative 1, negative 1. Then step 3, plot the points that have obtained earlier. Graph the axis of symmetry. So here, there's the vertex and the focus and the ends of the latus rectum. So based on observation, the parabola opens to the right. Based on the position of the points, the parabola opens to the right. So take a look at that. Then step 4, use the equation y minus k squared equals 4p times x minus h. Then substitute the values of h, k, and p. So since hk is negative 2, 1 and p is equal to 1, then just substitute y minus 1 squared equals 4 times 1 times x plus 2 So now we have y squared minus 2y plus 1 equals 4 times x plus 2. Y squared minus 2y plus 1 equals 4x plus 8. And then it will become y squared minus 2y minus 4x plus 1 minus 8 equals 0. So simplifying it, you're going to have y squared minus 2y minus 4x minus 7 equals 0. And that's the general form of the equation of the parabola. Then step 5, graph the parabola. Y squared minus 2y minus 4x minus 7 equals 0. So as you can see, the parabola crosses with the ends of the latus rectum as well as in the vertex. So obviously, we got the correct answer here. Students, you are very fortunate because you have access. So if you have internet connection, you can access GeoGebra in its website. Just type GeoGebra in the search engine. It will be found. You may also use Mathway, Symbolab, Microsoft Student. You may also download graphing calculator apps in your smartphones or tablets. Example number 3. Given the parabola x squared plus 4y plus 8x equals negative 4, find the vertex, focus, and the length of the latus rectum. Plot the points and graph the parabola. So, as you can see here, the equation is given in a general form. So, the first thing that we have to do is to write the terms with x together on the left side of the equation, then the terms with y in the left side of the equation. Then apply completing the square. We had completing the square from the previous lesson, so let me remind you about it. How do we complete a square? So look at 8x. What is the half of 8? 4. And what is the square of 4? 16. That's why 16 was added to x squared plus 8x. That's why it became x squared plus 8x plus 16. So by addition property of equality, we're going to add 16 also in the right side of the equation. That's why we're going to have x squared plus 8x plus 16 equals negative 4y minus 4 plus 16. Then combine negative 4 and 16, so you're going to get negative 4y plus 12. So x squared plus 8x plus 16 is a perfect square trinomial, and it can be expressed as x plus 4 square. In the left side or right side of the equation rather, just factor out negative 4, so you're going to have y minus 3. Here, you have now x plus 4 square equals negative 4 times y minus 3. And that equation is already in the standard form. So, if the equation of the parabola is in the standard form, we can easily determine the vertex. So here, obviously, the vertex is negative 4, 3. And p is equal to negative 1. Because there's negative 4 there. Since we can actually graph the parabola already since we have the general form of the parabola. The standard form of the equation of the parabola can also be used in graphing the parabola. So step 2 is find the following. So since the vertex is negative 4, 3, the focus is h, k plus p, so you're going to have negative 4, 2. The directrix is y equals k minus p. Substitute the obtained values of k and p. You're going to get y equals 4. Then the ends of the latus rectum, it's h positive or negative 2p, k minus p. You're going to get negative 6, 2, and negative 2, 2. The axis of symmetry is equals to, or is equal to x equals h, since h is then x will, since our h is negative 4, so it will become x equals negative 4. Then step 3, graph the parabola. So take a look at that. We got it right. Now it's your turn for practice exercises. Number 1, find the length of the latus rectum and the equation of the parabola whose axis is vertical at the origin and passing through 4, negative 2. Then graph the parabola. Number 2, find the equation of the parabola with vertex negative 3, 1 and focus at 1, 1. Then also graph the parabola. Number 3, find the equation of the parabola with vertex 2, negative 1 and the directrix y plus 2 equals 0. Also graph the parabola. Number 4, find the equation of the parabola with vertex 2, 2 and passing through 2, negative 2. The axis of symmetry parallel to the x-axis. Then graph the parabola. Lastly, number 5, given the parabola x plus 2 square equals 2 times y minus 1, find the vertex, directrix, focus, and the length of the latus rectum. For some challenger problems, number 1, find the point of intersection between the parabolas x squared minus 6x plus 4y equals 11 and x squared minus 6x minus 2y equals negative 1. Number 2, find the equation of the circle that has its center at the focus of the parabola x squared minus 2x plus 8y minus 23 equals 0 and is tangent to this parabola as its vertex. Number 3, given the parabola y squared plus 4x minus 3y plus 1 equals 0, find the vertex, directrix, focus, and the length of the latus rectum. Then number 4, graph the parabolas and the circle in number 2 based on the items 1 to 3 of the challenger problems. So if you want to practice more and learn more, you may visit these websites. I'm going to send these links to you, don't you worry. Always remember, class, the only way to learn mathematics is to do mathematics. Thank you very much for watching, for listening, and for understanding the lesson. Keep safe and God bless you.